All right, so unit 1 here, guys, so kinematics. We started out just reviewing scalar and vector quantities. Okay, that was kind of the start of the unit. So is it important to know which things are scalar and which things are vector? Yes. Is it because there's going to be a bunch of multiple choice questions asking about which things are scalar and vector? No. There might be one, maybe two, okay? But it's not something I'm going to waste a bunch of questions asking. But the reason you need to know which ones are scalar and which ones are vector is for problem solving. Okay? If a question goes something like this, a car rolls down a hill starting from rest and accelerating at 5.2 meters per second squared. After 5 seconds, what is the velocity of the car? Would you do that differently than if the question asked what's the speed of the car? Well, actually, you wouldn't calculate it any differently, but one of them would need what? One of them would need direction on it. That's where you need to know whether something is vector or scalar. Okay? If we're talking about something on a graph, it makes a difference as to how you calculate it. Okay? Calculating distance from a position versus time graph is done differently than displacement is. Okay? And so we need to understand, one is vector, direction matters, one isn't, direction doesn't matter, and we do those calculations differently. All right? So you do need to know which things are scalar and which things are vector. Okay? And here's our list. Okay? Scalar quantities, time, distance, speed, energy, work. We won't talk about those till next unit. Okay? Energy and work, but they are scalar. Okay? Our vector quantities, displacement, velocity, and acceleration. We need to keep in mind which ones are vector, which ones are scalar, because man, oh man, on this unit exam, guys, every year I do exactly the trick I just warned you about. Okay, I give a question that sounds like it's an acceleration question or something like that, and I ask for the final velocity, and people just brain fart it. Okay, and they forget that it needs a direction, and they lose a mark out of 5 because they didn't write up the hill or forwards, okay, on the answer. So keep in mind, some things are scalar, some things are vector. Vector things need directions on. Okay, that same day we reviewed the use of this formula, V equals D over T, and its companion, V equals D over T. Okay, for this first one, okay, this is the scalar one. V is speed. Okay, D is distance. Okay, T is time. All right, on this one here, this is velocity. Okay, this is displacement. Okay, are there going to be a whole bunch of questions that just ask you to do V equals D over T calculations? No. That's beneath you. Okay, however, do you need to be able to do V equals D over T calculations? Yes, because it could be part of maybe a graphing question, or it could be part of a projectile motion question. Okay, it's still something you need to know how to do. Just understand I'm not wasting a 5-mark question on a V equals D over T problem. Right? So there won't be anything like that. There could be maybe something in the multiple choice, okay, for 1 mark, a simple V equals D over T kind of question. Okay, but there certainly won't be a whole bunch of marks. Okay. Now, sorry, in terms of format, the exam is going to have some multiple choice, 21, I'll have to double check, okay, and some written response, some problems, okay, I think there's 7, I'll double check, okay, but you got a written response section with problems, and then you got a multiple choice section, okay, it's obviously got multiple choice questions. Okay, so that's the stuff on scalars and vectors, so we need to definitely know how to do that, okay, and the next thing we went over, and it's probably, it might be the biggest thing in terms of marks on the test. Graphing. Okay. Expect to see both a position versus time and a velocity versus time graph in the written response section of your test. Expect one of each. Okay. And expect a few graphing questions along the way in the multiple choice section as well. Now, the ones in the multiple choice will be more interpretation of the graph and less calculating. The ones in the written response are going to be more about calculating. Okay? What kind of things have I asked you to do with position versus time graphs?
Calculate displacement and distance.
Calculate displacement and distance. And what else?
Velocity.
And velocity. And speed. Okay, sometimes. Okay, and did we have to do y equals mx plus b with that graph? Okay, one of the two graphs is going to involve you using the graphing equation. Okay, either the velocity versus time or the position versus time is going to involve using the graphing equation to calculate something. All right, so if the question is worded like this, solve the following problem using your graph and the equation provided with it. Should you use the equation? Yes. Okay, this is one of those times where you don't think for yourself. Okay, just do what I say. Okay, because it'll make a big difference in your mark if you don't. I'm going to set the question up. So if you do it any other way, you'll get the answer wrong. Right? If it says using the equation or using the graph, use the equation. Okay, is that clear? I'll even make it like boldface, italicized, and underlined. Okay. All right. So position versus time graphs. Okay, that's our graphing lab, one where we had the carts just rolling along on the floor. We just gave them a push on the track. Okay, and we got the linear graph for position versus time. We calculated velocity, okay, from the equation of the graph, and so on. So expect similar things to that, okay, or expect to be asked to calculate again position or displacement from position, okay, and things like that. All right, so nothing you haven't done a bunch of times already. Okay, I'm going to ask you to do the same things we've done before. And then for a velocity versus time graph, okay, expect again to be asked to do the things we've done in class. Calculate the displacement, okay, from the graph. Calculate the acceleration from the graph, right? Things of that nature. Nothing we haven't done a bunch of times, but I would look at your lab. Right? Because the things I asked you to do in the analysis of your lab are the things I'm going to ask you to do on the test. All right, now you're probably looking at those graphs and going, what? So let me explain. So we have here on the left a velocity versus time graph, okay, and what we're looking at is an object that is doing what? It is accelerating. How do we know that? Because the velocity is increasing. Okay, we were given an equation for the line. Okay, if we're given an equation for the line, okay, and it maybe asks us to do something like calculate the displacement to 10 seconds, okay, then I would need to know what the value is of y at 10 seconds. Do you need to use the equation to get that? Yes. What if there's a point on the graph at 10 seconds? Should you use it or should you use the equation? Use the equation. Why? What's that? It might say use the equation, okay? But it also might mean that look where the point is. Okay? This little black dot is the point I'm talking about. Is it on the line? Then it's not finding the area under the line if you use it, is it? Okay? That's one of those things that we screwed up a little bit, okay, on the lab, okay, and in some of our graphing questions before on quizzes and stuff. So, okay, we need to make sure that we remember that. We're using the line here. So I would solve for what y is when x is 10, and then find the area of my two triangles, and then I would have, or sorry, my triangle and my rectangle, and then I would have my total displacement. Does that make sense to everybody? Okay, so little things like that. They're little details, right? Right? If I had a position versus time graph, what is this object doing? Moving forward at a constant speed, right? Okay, or at a constant velocity. How do we know that? Well, the amount of distance it covers every second is the same all the way along the line. Okay. Could I calculate the velocity of this object? Yes, I could. Especially if I had this. What's the velocity of the object? 1.5 meters per second. Is that something I might do on a test? If would I do that, would I give you the equation and then ask you to calculate velocity? How many marks would that be out of? Yeah. You would be shocked at how many of you will show me 6 marks worth of work. And it'll all be wrong. That's the really frustrating part. Okay, guys, if a question is out of 1 mark, answer's right in front of you. Okay, this does not require any work. Right, keep that in mind. That's a big juicy hint for your test. Okay, so definitely expect to be asked to do the things we covered about position versus time and velocity versus time graphs, and at least one of them is going to involve using the equation, okay, to do some of that calculating. So be ready for that. Okay, after that, okay, we talked about acceleration. Okay, there's going to be some acceleration problem solving in the written response. There could be some very simple calculations regarding acceleration in the multiple choice. Okay, like really, really simple. Okay, and in the multiple choice, I might ask you, like, I might check your understanding about accelerations. There might be a couple of situational type questions that don't involve calculations, but ask about acceleration. So kind of review your notes. What is acceleration? What does it look like? Okay, you're looking at a position versus time graph with an accelerating object. What would that look like? Right, it's a curve. Right, either it's getting steeper or it's getting less steep, flatter. Okay, those kind of things. Just keep those in mind. Those are the kinds of things I might ask. Okay, but there's definitely going to be some problem solving, okay, on the in the written response part of, like, just on its own, and also as part of projectile motion, right? You have to do acceleration problem solving in projectile motion, so it's in both places. Definitely practice that. Okay, and then vector addition, right? So there's a vector addition problem in the written response. Okay, we've done a whole bunch like it. Basically, every quiz you did on vector addition had a question like what's going to be on here. Okay, where can you see vector addition questions like what would be on the test solved?
Podcasts.
Yes, in the podcasts. Here's a really good place to look. Go into your Power School and look at your quizzes. For each quiz, there are 2 links. If you click on the task and it opens up the task window, okay, in the little details thing at the bottom, there'll be 2 links. One will say quiz 4 questions, and the other one will say quiz 4 solutions. Okay, so if you click on the quiz 4 questions, it'll open up that document that I posted the night before the quiz that has the 2 questions on it. Okay, and then if you click on the other link below, it'll open up YouTube, and it'll be the video of me going over those 2 questions and showing you the solution. Okay, good way to study. Try it. Watch and see if you did it right. Okay? You also have the worksheets that I gave you. You could try those. The answers are on there, but you don't get to see the solution if you get it wrong. Okay? So in that way, the quiz podcast is a little bit better, okay, in that regard if you're struggling. Okay? So definitely going to be on there. Okay? And there could be a couple of multiple choice questions, not involving calculations, but involving the principles of vector addition. We always draw them tail to head, things like that. Okay, just checking your understanding, okay, of how vectors work. Right, so there'll definitely be some of that. Okay, so tail to head. Okay, could there be a boat question? Yes. There's a boat question. And a tail to head question. Okay. All right, and then obviously projectile motion. There's one of each. So there's one projectile motion question involving a horizontally projected projectile, and one projectile motion question involving an angled projectile. Right? So if there's one of each type on there, they're pretty big marks, so you'll want to make sure you understand how they work. There's a couple of multiple choice questions, again, about the principles of projectile motion. Okay? No calculations, just principles of it. Okay, now a couple of things about the multiple choice, because this happens all the time and it's annoying. Do the multiple choice in pencil. That's those things, you know, that have the graphite in them and the little rubber thing at the top that you can erase the graphite part. Okay? The reason for that is this. Okay? When I scan the sheet, there is only one correct answer per line. If you fill in more than one, my phone will just say, it's wrong. And the phone's right, because there aren't 2 correct answers. And you said there were, and that's wrong. Okay? So, what you want to do is when you're doing the multiple choice, just fill in a little dot. And then when you're going over it and you're sure of your answer, then do this. And fill it all the way in. Okay? If you change your mind, use that little pink or white rubber thing that's on the other end of the pencil and take that out. don't do this. Oh, no, it isn't that one. It's this one. I was wrong. Oh, no, wait, no, it isn't that one. It's this one. You're making a really incorrect assumption here, and that is that I'm reading what you did there. I'm not. You put my phone over top, my phone scans it and tells me how many you got right or wrong. That's wrong. Okay? That's what my phone will say, and I'll agree with it. All right? So, erase things. Do not do that. Okay? Yeah, that's kind of a big deal. So, you're going to need a pencil. Okay? You're going to need a pencil for this test, and I mean, if you want a pen, you can have one, but I can't imagine what use it would be for you. Okay? You want to be able to erase mistakes if you make them even in the written response, so make sure you have a pencil. Okay? And then obviously your calculator. You won't get your formula sheet. I have put the formulas on the front of the test because I don't know how many notes to self you have written on your formula sheet. Okay? So you won't get that. So if you've written down every manipulation of every acceleration formula on your formula sheet, you better learn how to manipulate equations before the test. Okay? Because you won't have access to all of those on Tuesday on the test. Okay? All right, so a couple more details about the test itself if you want to write these down. Okay, so sorry, there's 17 multiple choice. That's right, I took like 4 of them out. Okay, so there's 17 multiple choice questions. And there are 7 written response questions. Okay, so those 7 written response, like I said, one is a horizontally projected projectile, one is a angled projectile, boat question, acceleration problem, graphing, vector addition, graphing. Those are your 7 questions, 7 problems. Okay, and then for the multiple choice, like I said, you're going to have some stuff about vectors, some stuff about difference between distance and displacement, speed and velocity. Okay, some interpretation of graph questions. So there's pictures of graphs on there, questions that ask you about the graphs. Okay, some stuff about acceleration. A question about the principles of vector addition. And a couple of questions about the principles behind projectile motion. Okay, for a total of 17. Okay. All right, so that is what is on your test. Okay, coming up here. And I posted yesterday on Google Classroom your unit exam review and the key for it. Okay, so that file is in there. Okay, so we've got the answers in there. Okay, you can check how you did, but that's the exam review. On this extra section here where it says extra kinematics review, okay, the answers are in brackets all the way along there. The challenge problems, I wouldn't worry about those. I'm never gonna, if you really want to be humbled, like you're starting to feel kind of cocky, okay, you can try those ones. For the most part, the ones that you see here in the first page would be like what you would see. This one here, this is a real thinker, is harder than I would ask on the test, okay? But there's lots of simple questions there, okay, for you to try, right? So activities I would suggest, okay, for you for preparing. The quiz thing I told you about, okay, do that. Go over some of your old worksheets, try the few problems, okay? If you're just picking a problem at random off of, all the worksheets and you're getting them all right, then you're probably in pretty good shape, okay? But you should be doing a lot of practice problems as a way to study for this test. Okay, obviously going over your notes is also still important. It just won't take you very long because you don't have a whole lot of notes to read. Okay, and those notes, are really only helpful for the multiple choice where it's checking your understanding. Okay, so those would be the activities I would engage in, okay, if I was preparing for this unit exam, like you are. All right, questions from you guys? Any questions that you have about stuff from this unit? Okay, then you have the remainder of class to prepare for said unit exam. My recommendation would be these questions. All right, and if questions come up, just ask, and I'll come around and help. Okay?